Hello, and thank you for coming. I'm going to be talking about detecting volatile organic compound emissions from compost facilities. My name is Bronstad, and I did not do any of this work. The work was conducted by Dr. Tom Jobson and his graduate student Nida Khosravi in the Civil and Environmental Engineering Department at Washington State University. Their research and this presentation both were funded under the auspices of the Waste to Fuels Technology Partnership, which is an ongoing collaboration between Washington State University and the Department of Ecology. The report that this presentation is based on can be found at that tiny URL at the bottom of the slide. It's posted on CSANR's website if you are interested in delving a little more into the source material. So compost facilities are known emitters of volatile organic compounds. Some of the ones emitted from compost can be precursors for air pollutants such as ozone and PM 2.5. Some, like aromatic hydrocarbons, are on the EPA's list of hazardous air pollutants, and some, like methane, can impact our greenhouse gas emissions. If a compost facility emits enough of these compounds, they could be subject to an EPA Title V air permit, which stipulates a threshold of 100 pounds of VOCs emitted per year, unless, of course, you're emitting hazardous air pollutants and that threshold drops pretty precipitously. California has led the US both in surveys and research surrounding compost facilities and in regulations focused on reducing these types of emissions from composting facilities in an attempt to address some air quality non-attainment areas in their state. Washington State, with respect to, in particular, ozone non-attainment areas, was doing pretty well as of April 2019, but Tri-Cities is becoming a bit of a concern with respect to ozone pollution. And because some of these VOCs can be precursors for ozone, ecology is starting to take a look at emitters of these compounds, in particular, for the purposes of this presentation, large composting facilities. So, inspired by California, ecology surveyed 6 compost facilities in Washington State between 2010 and 2013 for both the types of compounds that the facilities were emitting and in an attempt to determine the total VOC emission rate factor, which is pounds of VOC per wet ton of compost. It's calculated over the life cycle of the pile or windrow, which is approximately 30 days. And I bring that up because that becomes critical with respect to the data generated by the survey. WSU used ecology's data to do quite a number of things. First, of course, to figure out what compounds were being emitted from Washington State facilities, and to also evaluate whether or not the compounds could be generalized from facility to facility, to compare the compounds emitted from Washington State compost facilities to those that were being found in California, and to evaluate how the different compounds impact calculation of total VOCs using different analytical methods. They also use the data to determine potential environmental impacts of compost emissions in Washington State. So for the purposes of this presentation and for brevity, we're going to focus mostly today on the compounds, whether or not they can be generalized and how they compare to California, and also Washington State environmental impacts. There's a lot of information about analytical methods in the source material in the report, and I'd be happy to answer any questions about that particular component of the research in the live Q&A at the end of the presentation, if you're interested. So the survey had a few issues to begin with. 3 separate labs were contracted to evaluate the samples taken from the compost facilities. And unfortunately, there was not a common or uniform suite of constituents that the samples were analyzed for. So some labs detected methanol, some did not. So that made comparison across facilities a little tricky. And the sampling was only performed once at each facility, which made calculating an emissions factor impossible. And I want to take a few moments here to pull a few figures out of the report that I think illustrate pretty dramatically the importance of testing over the life cycle of that compost. On the left is a bar chart of total VOC flux. Flux is mass of VOCs emitted per meter squared per minute. In this instance, there on the right, on the y-axis. This data is representative of a Washington state facility. The survey in its sampling campaign took samples of different piles, obviously different aged piles, and you can see how different the emissions rate is for a fresh versus finished compost. On the right, this line graph is not from a Washington state facility. It's from a windrow in Modesto, California, that is not just food waste, but also green yard waste. The y-axis units are a little bit different, but it's still a rate. It's still pounds of VOC emitted per day. And again, if you're taking that sample on day 3 or day 8 or day 21, your evaluation, your results are going to be very different. So with respect to the compounds detected at each of the facilities, I'm going to highlight a few groups of compounds for a reason that will be evident later in the presentation. So light alcohols, methanol, ethanol, isopropanol. Unfortunately, methanol was only evaluated for facilities 1 and 2 at lab 1. Labs 2 and 3 did not report. Ethanol seems to be a fairly hefty portion of facility 4 and 6 emissions. Our monoterpenes, alpha-pinene and limonene, again, 4, 5, and 6 seem to have some substantially high monoterpene emissions, but we don't know about 1 and 2, facilities 1 and 2. So a little bit of discrepancy and inconsistency across reporting for compounds. Task 3 was to use the data and compare the compounds that were being found in Washington to those being found in California. And using an EPA speciate emissions data for green waste compost in California, the emitted compounds across the states are significantly different. In California, light alcohols dominate, in particular isopropanol, which was approximately 40 to 42% of the VOC flux, whereas in Washington it was non-detect. And in Washington it's monoterpenes, those limonene that were very high in the previous slide. And why is that important? Well, in particular, monoterpenes can contribute to ozone production in areas with elevated NOx emissions, and they also can contribute to PM2.5 formation. So again, very different profiles of compounds across the states. I just want to emphasize again, isopropanol was the primary or one of the greatest emitters found in California. We have no detect in any of the Washington state facilities. So what tasks 1, 2, and 3 indicate is that we definitely in Washington State need more research and more evaluation across uniform suites of compounds to really get a handle on what is going on at our own compost facilities. Skipping over task 4 again and going to task 5, which was evaluation of environmental impacts, potential environmental impacts of compost emissions here. So again, we turned to California because they developed an equation in 2015 to estimate annual emissions from green waste composting facilities that took into consideration the compost emissions factor as well as a control technology efficiency. Control technology being a biofilter or any other system or technology that would ameliorate the emissions at the compost facility. Looked at throughput for the facility, the stockpile emission factor, and the amount of time the stockpile was sitting on site. Not only they developed this equation, they developed recommended factors to use in the equation, the compost emissions factor. I have to say this 3.58 is an average of 9 facilities in California that demonstrated quite the breadth of emissions factor. One facility's emissions factor was 1 pound per wet ton, another's was 10 pounds per wet ton. So there's obviously some variability. Nevertheless, this is a recommended average factor by CARB for use in estimating annual emissions. So Dr. Jobson's team used this average VOC-EF, assumed a 1-day average time of per stockpile, assumed no control technology efficiency, and looked at the compost facilities in Washington State and their annual throughput. And using that data, they evaluated or estimated the potential annual emissions for compost facilities in Washington State. And doing so, they found that 7 facilities in Washington potentially exceed the annual VOC emission thresholds. There were a few other issues associated with the survey that I'd like to touch on. There were questions regarding different analyses and methods. There were some EPA methods used by the Washington State labs for VOC analysis, but unfortunately, they didn't use the same methods across the board. And so some of the results are non-comparable. The California studies used a more rigorous EPA method, but for reasons that you can definitely find in the report that I won't go into here, even though that's a more rigorous method, if you're evaluating a compost that emits mostly light alcohols, you will significantly underestimate the VOC emissions. So there's still some work to be done for determining what the best analytical methods are. I want to bring us back to this table because, again, even though Washington State seems to have sort of their emissions fall into the monoterpene bucket, there are still some substantial light alcohols that are showing up in several of the facilities tested. And so again, even if the labs had used the more rigorous EPA method 25, it is still possible that emissions factors, or excuse me, that the emissions, total emissions would be underestimated at, for example, facilities 4 and 6. So for this biennium of work for the Waste to Fuels Technology Partnership, Dr. Jobson has several tasks. First, let's just make up some compost and test it. They will test it continuously versus frequent grab sampling and use the results of each of those sampling techniques to help improve sampling methodology, develop and optimize field sampling methods, and get a better understanding of analytical methods for the compounds emitted and calculating a total VOC emissions more accurately. There were several other field sampling issues that I didn't mention that we can talk about in the live Q&A if you would like. He's also charged with comparing emissions profiles and rates between the lab and the field to see if the lab measurements can be used as a proxy. Again, if this is going to be done right, someone's going to be out there at the compost pile every day taking lots of grab samples, or there's going to be an expensive piece of equipment doing continuous sampling. So can the lab work approximate field conditions for a more economical evaluation? And finally, a full-scale emissions testing campaign at the WSU compost facility is planned to take all of the laboratory-derived knowledge and apply it in the field, but also to determine a biofilter effectiveness for removing VOCs at compost facilities. So stay tuned. And that is my time. Thank you very much.